Hello, I'm Michele Chiari, and I will show you how we model check the pushdown specification based on Operator Precedence Languages, a subclass of structured context-free languages. So in model checking, we verify whether a system model is compliant to a specification. The kinds of properties that can be verified depend on the formalisms that we use both for the model and the specification. With temporal logic such as OPTL for the specification, we can only express properties that are equivalent to a regular language. This is a problem if we want to verify procedural programs, because it's impossible to match procedure calls with their returns and express, for example, pre- and post-conditions for functions. To do this, temporal logics based on VPL have been introduced. Visibly pushdown languages, VPL, are a subclass of deterministic context-free languages, so they are more expressive than regular languages. However, we push the expressive power of temporal logic one step further by introducing POTL, a temporal logic based on OPL, a class of languages even more expressive than VPL. But what are the advantages of using OPL? Well, the main gain is a richer representation of time. In LTL, we just have a linear succession of discrete events. With CaRet and other logics based on VPL, we have nested words, which add a binary nesting relation which is ideal to model function calls and returns. Such logics have temporal modalities that can interact with this structure explicitly. For example, we can state that a certain procedure never calls another one. However, this nesting relation can be only one-to-one, which cannot represent exceptions, because they can be matched with the calls they terminate. With OPLs, the relation can be also many-to-one, so we can reason on exceptions, continuations, and other features of modern programming languages. So, we can say things such as this procedure is never terminated by an exception, or if this procedure writes to that variable, an exception is thrown. So, we introduced a new temporal logic, POTL, which captures the first-order fragment of OPLs. We give an automata-based model checking algorithm, and we implemented it in a tool named PONC. Now, let's see what POTL can do with some case studies. Here we have a simple banking application in Java, where users can withdraw money or check their balance. Users have read-write permissions, and we must check that no protected operation is performed when a procedure issued by a user that does not have the appropriate permissions is on the stack. This is called stack inspection. We modeled this program with PONC and successfully verified that an exception is thrown whenever an illegal operation is performed. And as you can see, we did so even in quite a small amount of time. The next one is about exception safety in C++. So in C++, generic containers, such as a type parametric stack or a vector, should provide some guarantees on their behavior when the contained objects throw. A container is exception safe if it remains in a valid internal safe state when an exception is thrown while performing an operation on it. So for example, if we push something on a stack and the constructor of what we push throws, then after the exception, the stack must be still in a valid state. A container is exception neutral if exceptions thrown by elements are propagated outside of the operations of the container. We modeled two implementations of a generic stack and successfully proved that one of them is exception safe and the other one is not. Also, both of them are exception neutral. And as you can see, we did both things also in quite a short amount of time. So to conclude, if you're interested in our work, please watch the longer video, and you may also try out our artifact, which is on Zenodo. Also, our tool, PONC, has been released with an open source license on GitHub, so check it out. In the future, we plan to try more efficient techniques for model checking, and also to use some proper abstractions to model real programs. Thank you for your attention.